in C++. Inheritance is a process in which one object acquires all the properties and behaviors of its parent object automatically. That means in C++, the class which inherits the members of another class is called derived class, and the class whose members are inherited is called base class. Generally, so the benefit of using inheritance in C++ is code reusability. Code reusability. That means we can reuse the members of your parent class. So there is no need to define the member again. So less code is required in the class. So you can automatically reduce the length of the code. In inheritance, there are so many types, and supports C++ supports 5 types of inheritance. That is single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, hybrid inheritance. Inheritance is the process by which a new class called derived class are created from existing class called base class. Just we discussed, no? That is that the derived classes have all the features of the base class, and the programmer can choose to add new features specific to the newly created derived class. The idea of inheritance implements is a relationship. It is the relationship. A derived class is defined as the class derived from the base class. Generally, the syntax is class derived, and here we can give the class name, a scope resolution, visibility, then mode, base class name. So below that we can write the body of the derived class, where the derived class name is the name of the derived class in syntax. Visibility mode means the visibility mode specifies whether the features of the base class are publicly inherited or privately inherited. It can be public or private. Here, when the base class is privately inherited by the derived class, public members of the base class becomes the private members of the derived class. Therefore, the public members of the base class are not accessible by the objects of the derived class, only by the members functions of the derived class. When the base class is publicly inherited by the derived class, public members of the base class also becomes the public members of the derived class. The public members of the base class are accessible by the objects of the derived class as well as by the members of the functions of the base class. Here you can observe one thing. In C++, the default mode is of visibility is private. The private members of the base class are never inherited. See here in this slide. And dog is the mammal. It has all the features of mammals in addition to its own unique features. And cat is a mammal and it has all features of the mammals in addition its own unique features. So that is the inheritance. And basically the advantages of inheritance is the reusability of code. That means it is no need to write again and again. We can use it. You can reuse it and saves the time and effort. It's a time saving factor. Faster development, easier maintenance and easy to extend, and capable of expressing the inheritance relationship and its transitive nature, which ensure closeness with the real world problems. And this is the syntax. Just we discussed it in the previous slide. This is the syntax. Same thing. Single inheritance is defined as the inheritance in which a derived class is inherited from the only one base class. For example, A to B, where A is the base class and B is the derived class. When one class inherits another class, it is known as single level inheritance. Single level inheritance. The private member is not inheritable if we modify the visibility mode by making it public, but this takes away the advantage of data hiding. So when we are going to use the private, data hiding will be possible. When it is making public, data will not be hiding. C++ introduced a third visibility modifier, that is protected. The member which is declared as a protected will be accessible to all the members functions within the class as well as the class immediately derived from it. Visibility mode can be classified into three categories. Visibility mode that will be classified into public, private and protected. Whereas public when the member function when the member is declared as public, it is accessible. It is accessible to all the functions of the program. That is public. And that is next private. When the member is declared as private, it is accessible within the class only. Within the class only. So protected means when the member is declared as protected, it is accessible within its own class as well as the class immediately derived from it. In this syntax, a class can be derived from more than one class, which means it can be inherit data and the function from multiple base classes. In that case, a class derived lists name of one of or more base class is separated by comma, as shown in the syntax. For example, multiple inheritance. Multiple inheritance is a process of deriving a class from another derived classes. For example, A, B, C, and A to B and B to C. This is the multiple inheritance example. When one class inherits another class, which is further inherited by another class, it is known as multi-level inheritance in C++. Inheritance is a transitive, so that last derived class acquires all the members of its base. When one class inherits another class, which is further inherited by another class, it is known as multi-level inheritance in C++. Inheritance is transitive, so that last derived class acquires all the members of its base classes. Access control and inheritance. Derived class can access all the protected and public members of its base class. Observe the slide. This is the same continuation. Multiple inheritance is the process of deriving a new class that inherits the attributes from two or more classes. Usually we can write the syntax like class D. Just small example. Class D, visibility B1 and visibility B2. So you can use with the commas. We can write more than one thing, and then here we can write the body of the class. Ambiguity resolution in inheritance can be occurred in using the multiple inheritance when a function which is the same name occurs in more than one base class. So next come to the visibility modes and inheritance. So private, protected and public. So we explained in last slide, no? Just observe the slide. And private, protected and public. Private, not inherited, and protected become a private of class, child class, and public means become a private of child class. Protected means not inherited, same thing, private, and become a protected member of the child class. Something like become a protected member of child class in this public. So in third one, not inherited, same thing, become a protected member of child class, same thing, and become a public member of the child class. The differences. And visibility modes and inheritance. Visibility modes. Observe the slide, we can understand. Same thing here. Same thing, private, public and protected. Private inheritance. Private inheritance. And this is the example for the protected inheritance. Protected inheritance. And this is the example program for the public inheritance. So where hybrid inheritance is a combination of more than one type of inheritances. So A will come to the B and A to come to the C and B to go to the D and C go to like that. More combinations. So more combinations. Hierarchical inheritance is defined as the process of deriving more than one class from a base class. Base class. Order of priority. In sequence it will derive in more. An example. This one, types of inheritance, single inheritance and multiple inheritance and multi-level inheritance and hierarchical inheritance and hybrid inheritance. The capability of class to derive properties and characteristics from another class is called, generally we can call it as inheritance. Inheritance is one of the most important features of OOPS, object-oriented programming. Of course, the class that inherits properties from another class is called a subclass and derived class. And the class whose properties are inherited by subclass is called as base class, or we can call it as also superclass. The single inheritance is the one where you have a single base class and a single derived class. Base class also called as superclass and subclass also derived class. This is single inheritance. This is the best example of single inheritance program. Just a small example, consider a group of vehicles. You need to create the classes for bus, car and a truck like that. The methods, fuel amount, capacity, apply brakes. So it will be same for all the three classes. Even bus or car or truck, anything, this is the same properties. If we create these classes avoiding inheritance, then we have to write all these functions in each of the three classes as shown. This is first one is class bus, class car, class truck, and fuel element, capacity, apply brakes. Same thing in this car also, fuel amount, capable capacity, apply brakes, and truck also same thing, same thing. But different classes are different, but the features and everything is the same. We can clearly can understand the process result in duplication of the same code in 3 times. This increases the chances of error and data redundancy. To avoid these type of situation, inheritance is used. If we create a class vehicle and write these 3 functions in it and inherit the rest of the classes from the vehicle class, then we can simply avoid the duplication of the data and increase reusability. Using inheritance, we have to write the functions only one time instead of 3 times, as we have inherited the rest of the 3 classes from base class. Implementing these inheritances for creating a subclass which is inherited from the base class, we have to use it. This is a multiple inheritance, a subclass inheritance from the class that itself inherits from the other class. This is a multi-level program example. This is also multiple inheritance. A derived class inherits from multiple base classes. It has properties of both the base classes. Here we can notice one thing. A derived class does not inherit access to private data members. However, it does inherit a full parent object which contains any private members which that class declares. And this is the multiple inheritance. Example, we can observe this slide. This is the hierarchical inheritance. Hierarchical sequence. This is the example, program example, hierarchical inheritance. In public mode, if we derive a subclass from a public base class, then the public member of the base class will becomes public in the derived class, and the protected members of the base class will become protected in derived class in public. So we know that it is a public mode and protected mode and private mode, you know that. And the second one is the protected mode. If we derive a subclass from protected base class, then both public member and protected members of base class will become protected in derived class. Okay. And next one is the private mode. If we derive a subclass from private base class, then both public members and protected members of the base class will become a private in derived class. We can observe here that private member in the base class cannot be directly accessed in the derived class, while protecting members. Okay, and this is a hybrid inheritance slide. Observe this hybrid. The combination, more combination are there. Hybrid inheritance is implemented by combining more than one type of inheritance. Just like combining hierarchical inheritance and multiple inheritance, like that, more than more than one combinations. A derived class with two base classes, and these two base classes have one common base class is called as multiple inheritance, and ambiguity can arise in this type of inheritance. So there are two ways to avoid the ambiguity. There are two ways to avoid this ambiguity. First one is the use scope resolution operator, and the second one is the use virtual base class. So first can you see the scope resolution operator. Using scope resolution operator, we can manually specify the path from which data member will be accessed. And the second one is virtual class. Avoiding the ambiguity using virtual class. A derived class does not inherit access to private data members. However, it does inherit a full parent object which contains any private members which that class declares. For creating a subclass which is inherited from the base class, using inheritance, we have to write the functions only one time instead of more times. Ambiguity can be occurred in using the multiple inheritance when a function with the same name occurs in more than one base class.